All right, so the next topic at hand is going to be your geometric sequences. And so let's talk about what a geometric sequence is, how it differs from an arithmetic sequence. For the arithmetic sequences, what we had to do was add the same value, which was called your common difference each time. And with a geometric sequence, instead of adding, what we're going to be doing is going to be multiplying by the same value to the previous term throughout the sequence. So the number that you multiply by is going to be called your common ratio. And the letter that we use for that in our formulas is going to be R. And so once again, we're going to have two types of equations. You're going to have your explicit equation, and you're going to have a recursive equation. And your explicit equation for finding the value of any term in your sequence is going to be a sub n equals a sub 1 times r raised to the n minus 1. And then your recursive equation for finding the next value in your sequence is going to be a sub n equals a sub n minus 1, which once again just refers to your previous term, and you're going to be multiplying your previous term times that common ratio. All right, so let's take a look at the first example here. We are given that a sub n is equal to a sub n minus 1 times negative 1/2. This is your recursive equation. Your recursive equation, remember, is a sub n equals a sub n minus 1 times r. Well, what this tells us is that our common ratio is going to be negative 1/2. So we are also told that the third term in this series is going to be 6, or this sequence rather is going to be 6. So let's think about how we would get the third term. If you had the first term, the second term, and the third term, and these kept on going, fourth, fifth, I'll just write all these out here, 6th, 7th, and 8th, because we're eventually going to be trying to find out what is the 8th term. All right, the one thing we do know at this point is that the third term is 6, and this would be a sub 3. Now, what if I want to find the value of the first term? Well, I know that if I multiply the first term by r, that will give me my second term. And if I multiply by r again, that will give me the third term, which means a sub 1 times r, and then times r again, which would be times r squared, has to equal 6. All right, well, we know that r in this problem is negative 1/2. So let's fill that in. Well, negative 1/2 squared is 1/4, and it's positive. And that means if you multiply by 4, a sub 1 is going to equal 24. All right, so that is the value of our first term. All right, so from here, let's go ahead and do some multiplication to find the value of each term. So if you multiply the first term times r, that will give us the next term. All right, so 24 times negative 1/2 is going to give us negative 12. Negative 12 times 1/2 is 6. 6 times negative 1/2 is negative 3. Times negative 1/2 is positive 3/2. Times negative 1/2 again is negative 3/4. times negative 1/2 is positive 3/8 times negative 1/2 is negative 3/16. All right, so that means our a sub 1 that we were looking for was 24, and a sub 8 is going to be, this was over 16, a sub 8 is going to be negative 3/16. All right, so what I want you to do is go ahead and pause this video, write this problem down, and I want you to work this out similar to what we did in the previous slide, and then unpause the video and you can check your answer. All right, welcome back. So in this particular problem, you're going to notice that you have a sub n equals this times 2/3, which means r, your common ratio, is 2/3. We're given that the fifth term is 48, and so that is this term right here. And so a sub 5 is 48. We were trying to find the first term to start out, and if you multiply the first term by r once, twice, 3, 4 times, so that means a sub 1 times r to the 4th power would have to give us 48. We can plug in what the r value was, which is 2/3. And 2/3 to the 4th power would be 2 to the 4th, which is 16, over 3 to the 4th, which is 81. Multiply both sides by 81 over 16. Now, you can reduce this thing if you think about 16 goes into 16 once, 16 goes into there 3 times, then you're just multiplying 3 times 81, which is 243. That means our first term is 243. Now, to find the next term, you would take that 243 and multiply it by your common ratio of 2/3. And once again, what I would do with this is cross-reduce. 3 goes into 3 once, 3 goes into here 81 times. Then you're multiplying 81 times 2, which is much easier. That gives us 162, which we multiply by our common ratio once again. And that gives us 108 for the next term. And then 108 times 2/3 gives us 72, times 2/3 gives us our fifth term, which was 48. And then 48 times 2/3 will give us our sixth term, which is 32. All right, so in this problem, we are given your second term is 4/9, and your fifth term is 3/16. And we want to know what is our common ratio and then what is our first term. All right, so I'm just going to write this out kind of like I did on the previous problems here, just so you can get a little visual of this. We have a total of 5 terms here. We have a sub 1, a sub 2, a sub 3, fourth, and fifth term. And we know that the fifth term is 3/16, and we know the second term is 4/9. Now remember that if we multiply this term by r once, twice, 3 times, we will get 3/16. So that really gives us our equation. Our equation would be 4/9 multiplied by r 3 times, or r cubed, would have to equal 3/16. What we're trying to do is find out our common ratio, r, so we're going to solve by multiplying both sides by 9/4. All right, so that reduces. That leaves us with r cubed equals, and this is going to give us 9 times 3 is 27, over 16 times 4 is 64. All right, so our next step is to get rid of the cube by taking a cube root of both sides. The cube root of r cubed is just our r. The cube root of 27 is 3. And the cube root of 64 is 4. So that gives us our common ratio of 3/4. All right, so if I multiply, let's see, common ratio is 3/4. If I multiply 4/9 times 3/4, that will give us our third term. And so the 4's will cancel. 3 reduces, and that would give us 1/3 for the next term. So this term is 1/3. Now if I take the 1/3 multiplied by 3/4, our common ratio, that would give us the next term. The 3's cancel, which will give us 1/4. And if you multiply 1/4 times 3/4, that would give us our last term as 3/16. Now we need to find out that first term. Now if you think about this, a sub 1, which is our first term, multiplied by the common ratio of 3/4 would have to give us the second term, which is 4/9. So if I want to find a sub 1, I would multiply both sides by the reciprocal. So that means a sub 1 will end up equaling 16/27. All right, go ahead and take a second to pause the video and write this problem down and work it similar to how we worked the previous problem. And then you can unpause the video and reveal the answer. Okay, welcome back. As you can see, what we did is we took our third term of 8/9 and we said 8/9 multiplied by r once, twice, 3 times, so 8/9 times r cubed is equal to the 3/8. Multiply both sides by 9/8 to reduce this, and you end up with 27/64 here. And then you take the cube root of both sides, and the cube root of 27 is 3, and cube root of 64 is 4. That's our common ratio. All right, so what we did then is we said that to find the first term, we had to multiply the first term by the common ratio once, twice, so the first term times r squared to give us that 8/9. Well, the common ratio we just found was 3/4. So squaring that, you get 9/16, and then you multiply both sides by the reciprocal value here. So that cancels, and this comes out to 128/81. And that is our first term. Now you can get all the other terms. It didn't ask it up here, but if we want to complete this sequence out, 128/81 times 3/4 will give us this, times 3/4 again gives us this term, times 3/4 gives us this, times 3/4 is that, and then times 3/4 again is this fraction here on the end. All right, so this problem says given a sub n is a sub n minus 1 times 2. So right away from that, we recognize that is our recursive formula, which means the common ratio is 2. So we can get that right off the bat. We know the fifth term is 264, and we want to find the first term. All right, so let's go ahead and write this out like we did in the others. We have 5 terms that we are dealing with. So I'm going to go ahead and write these down. A sub 1, 2, 3, 4, and 5. And our fifth term was given to us as 264. Now, from this, we know that if we take that first term and multiply it by our common ratio 1, 2, 3, 4 times, so that means a sub 1 times r to the fourth power, that is going to give us 264. Well, we know that the common ratio is 2, so 2 to the fourth power is 16. And then we're going to take 264 and divide it by 16, which is going to give us 33 divided by 2, and that is going to be our first term. And we can check this, because if we multiply 33 over 2 times 2, that will give us our next term, which would be 33. Times 2 again is 66. Times 2 again is 132. Times 2 is 264. But to answer our question, the first term is 33 over 2. All right, I want you to use the process that we used for the previous problem. I want you to pause this video, write this question down, work it, and when you're finished, you can pause and check your answer. Okay, so welcome back. When you have a sub n equals 4 times a sub n minus 1, this means that 4 is our common ratio. It doesn't always have to be a sub n minus 1 times r. That's the same thing as saying r times a sub n minus 1, and that's the situation that we have right here. So the common ratio is 4 right here. So we set up an equation. We said that, well, if this is our first term and this is our fourth term, then a sub 1 multiplied by the common ratio 1, 2, 3 times, so a sub 1 times r cubed would give us 384. Well, we know the r value is 4, and 4 cubed is 64. So if you divide 64 to the other side, that gives us our first term is 6. And 6 times 4 is 24, times 4 is 96, times 4 is 384. Again, just completing the sequence here, that just verifies that the work that we have done is correct.